The title of the talk, as you can see, is Engaging the Public in Genetically Engineered Crops. And I do want to say that it's a massive topic, so 15, 16 minutes is not going to really be exhaustive, and there will be things I would be glad to say during the discussion, but I'll do my best. Anyway, I'd like to start by asking you, what are some of the concerns and questions that you've heard on genetically engineered crops? Yes?
That they decrease biodiversity.
So that they decrease biodiversity, okay. What else? So how are you going to control what you put out there, like maybe the spread of genetics in some way? Okay, good. Spread of the genetic material. What else?
They give you cancer.
They give you cancer. Okay, got it. How do you absolutely assure me that they are safe? Okay, great. And so now if I did this in a real public presentation, I would be writing these on the board or writing them on a pad so that you see that I'm listening, right? Do you feel that I heard your concerns? I mean, or the points you made? So I did, and writing them down helps. And I make sure I go back to those. So, by the way, there's not enough of those handouts, so do share if you can. And anyway, I got experience with dealing with contentious issues when I started providing outreach on global warming, climate change, and crop production in Kentucky, and boy, did I get slammed by the county agents. The county agents tell us that we are tell the public we are a research-based institution, and yet they resisted this whole topic. Many of them did, not all of them. And what I didn't understand at the time, I was totally dumbfounded by this. But what I didn't understand is that statistics do not evoke personal meaning. So data matter to us, but in general, the general public do not depend on data the way we do. And so we scientists, I've read this in the social science literature, and I believe it. It's absolutely true. We follow the information deficit model. We think that public action on an important issue depends on filling the void of knowledge that they may have. And so we'll just fill it. And you really, in science, you must work that way in this setting, right? You come with all your data, and we want to see all of your data, right? And we want to hear about it in seminars. But that's not how we're going to communicate science to the public. And so we all, I think every one of us makes this mistake of following the information deficit model. Let me just fill that hole and everything will be fine. In fact, with respect to climate change, the positions on climate change convey values and have cultural significance. In other words, it tells me something about the team you belong to, right? By just knowing what you think about climate change. So one of the most important things I've learned about science communication, and these are themes we've heard multiple times with these other speakers today, and with Jack Bobo, and I think his name is Jack, and the session yesterday from Minnesota. Presenting the science is necessary, but not sufficient to communicate, and especially if there's a sort of a controversial aspect of the topic. It's not enough to just present the information. And in many respects, the same is true for genetically engineered crops. So I'm just going to hit on a couple points, random scattered. Most of these are in that document, but not all. First of all, I think it's important, if you're going to talk about genetic engineering, to disclose all the funding that relates to that, particularly industry, private sector funding. It doesn't disqualify you from talking about this subject, but it is important to just put it out there for the public to know about, and I think it's a trust issue. So with respect to this publication, let me hit on a few points. First of all, what I think you just saw is that I have learned to let critics speak first. It's really hard to do. We know a lot. We want to share what we know. We know it's important what we know, but let them speak first, and then listen to them. Listen to what they're saying, and make sure to reflect it back. So what you're saying is that you're worried that these are unsafe. And then they feel heard, and then there's a better chance that they will listen. It really is really powerful, actually. I mean, there's no guarantee, as Kirsten and Juliet have said. Not everybody will react to this the same, but I have seen it really be very helpful for me. So people are scared about these crops, and I always show this picture in a setting with the public, and then I say, and then notice the big X. So I'm really kind of trying to erase the image, and I base that on the National Academy of Sciences, the European Academy of Sciences. So I tell people that is not what the science shows. But I don't do it with data. I don't even do it with the reports, but I do it with a graphic that I can defend, as Kirsten, I think, was saying. What I say is defensible, but I'm not doing it with the typical kind of scientific figures. You know, when somebody says they're unsafe, that's really tough. I'd have a tendency to respond emotionally, and because I feel like we're being insulted. Of course, you know, it's safe. I mean, why would so many people, thousands of dedicated scientists, be, you know, anyway. So I try to take a breath or two and think, as you all were saying. And this is an important slide. There is an intersection of shared values, right, between somebody who may be very sort of in line with conventional agriculture versus somebody who might be very into organic or biodynamic agriculture. There is a zone of shared values, and what would it be for the issue that was raised? They're unsafe. What would be the shared value? Well, it could be kids. Why? What about kids is important? Right. So that's right. So we want to know that those kids are eating safe food, right? I want to know that the food I'm eating or that my family's eating is safe. So that's the shared value. We all want safe food. And if I can remember to say that instead of responding defensively, then we may not agree about how we get there, but at least they know that I want safe food. And frankly, I think I can speak for all of you that you want safe food too. So no matter what your position on genetic engineering, that's a shared value. We share numerous. Food security for all, food sovereignty for all. I think if you think about those aspects, you're going to be in agreement with those. This is probably the best way, though, because at least in the presentation, I always show it. I say, look, my family, I don't have any concern that my family eats genetically engineered foods. I hope they don't eat too much sugar, but or too many saturated fats, but I'm not worried about genetic engineering because I've studied the science intensely and I know what it says, and I'm not worried about it. And that's the most powerful way that I could. Even showing the report of the National Academy of Sciences is not as powerful as this. And it's an image. You notice it's an image. It's a what does my fiance call him? She's a social scientist. I can't remember the phrase, but it's an image that conveys the point, right? Very simple. I think it's important to talk about both benefits and risks or concerns. So there's a benefit that virus-resistant cassava that has been developed by an African scientist for Africa, and I don't think I have the right to tell him that he shouldn't be doing that. In fact, he's done some wonderful work. But I also think it's important that we talk about risks, and I would say one of the ones that kind of surfaces for me is the whole herbicide tolerance trait, whether it's genetically engineered or conventional. That's not it's got a lot of benefits. I know the benefits, trust me. I respect the farmers who use them. And it's not a sustainable way to control weeds. We know this. Farmers know it. So that would be one of the risks that I would highlight. But we've got to be willing to talk about both to have the credibility. And again, I think it relates to something one of you both said. High impact image, that's the phrase, Judy's phrase. So that's a high impact image. I always make sure they know that aflatoxin contamination in corn is a really serious issue in the tropics where they eat corn, really serious. And they don't have the food system protections that we do. And there is a very strong possibility that genetic engineering, based on the research to date, is going to really significantly help with this contamination issue. I'm in favor. But I convey it with an image. How are we doing on time? How much more? 7 minutes? Okay, good. So this is a diversion from the handout that I give, but I like to show a few ways to explain the basic biology of genetic engineering, because it is important to be able to connect to people on this, what does it actually mean? And so I've got here some dried cranberries and some peanuts, and they're both non-GMO, of course, because there are no commercial GMO cranberries or peanuts. And sometimes when I do this, people in the audience go, like, what is he doing? So raise your hand if you think I'm eating DNA. A room full of biologists, I never fool anybody. But with the public, it's wonderful because at first there's about 3 or 4 seconds where everybody's looking around like, is this a trick? And of course, somebody eventually gingerly raises their hand, and I, affirm them and thank them. So DNA is in all our food. I start with that, and in a way that is kind of disarming. This I have found helpful. I don't know if it's my idea or somebody else's, and I can't remember who to credit it to, but I like to use the analogy of word processing. And so, I think of genes as like sentences composed of letters, and how many letters are there in the DNA alphabet? Does anybody know? And of course, somebody always knows 4, and so it's a very good analogy. And they all know that if they copy and paste a sentence from one file to the next, it doesn't cause the computer to explode. And the same is true with words. That words don't harm us. It's only the way they're arranged that can matter. But the words themselves don't harm us, and the copy and the pasting of the words don't matter. And so this is also helpful to understand older transformation techniques. It's like a copy and paste mechanism, which can result in random integrations of the DNA. So, that's maybe the most significant limitation of transformation. But they can understand it. And the latest techniques, CRISPR techniques for this audience, actually I say CRISPR for all audiences, allows targeted edits. So here we go. Here's an example. Wine is made from grape juice. That's not right. So we can fix that with CRISPR, genome editing. Or maybe we've got an extra letter that shouldn't be there, so we can fix that with CRISPR genome editing. So they, with a few simple ways, they can understand the basics of genetic engineering. These have been useful. Again, the analogy of using word processing to understand genetic engineering, I think, is useful because it reflects the science. And that is, with genetic change, it does not matter how the genetic change was made. What matters is what the change does. Just like, we can erase a letter and write it in with a pencil here, or we can copy and paste. It doesn't matter how the letters were changed. What matters is what the change does, just like genetics. And another point that people are interested in, how are we doing? Okay, thanks. Is this, and I didn't know this till I started intensely learning about genetic engineering for outreach, and that is, it actually is a more precise way and less impactful way to manipulate, to affect plants. And so for this audience, I'll say what I mean by that is genetic change is less, transcriptomic effects are less, proteomic effects are less, and metabolic effects are less. This is all documented in the literature. So, but I just stick to the less impactful on the plant. And you can read about that in my article on sustainability. Many papers cited there. And I will make you aware of a YouTube video, which makes for a great way to illustrate this point. Which all you need is 4 decks of cards, and you can find it on YouTube. Just search my name, and crop genetic engineering maybe would be included in that Google search. But you'll see it's actually easy to help people understand that actually conventional breeding causes more disruption to the plant than does genetic engineering, so that you can find that. Finally, a few last points here. I really believe this is what motivates me, is I believe that at least for disease and insect control, we're going to be able to reduce pesticide use if using genetic tools, including genetic engineering. And so if we want to reduce pesticides, I tell people we must give farmers alternatives. There's a farmer spraying Bravo in fungicide in Central America, and I'd like to give him alternatives too. And so if we want to reduce pesticide use, we must give farmers alternatives. And probably the most powerful image is that little girl about 10 meters away from that rice field in Central America, and that rice field gets treated with pesticides, and so does she, I suspect. So if we want to reduce pesticide use, we must give farmers alternatives. And I don't care where those alternatives come from as long as they're safe. And that's just a visual of developing nation with using genetic engineering to reduce an important problem on a culturally important crop.